Welcome back to YMT114 Principles of Software Engineering. We are still discussing Chapter 6. We have covered Part 1 of the architectural design, and we spoke about the definition of architecture, the difference between architecture and design itself as a process, and we spoke about a lot of details in the first part. Now, for this part, we will try to cover other aspects. The pattern, we'll speak about architectural pattern. We spoke a little bit about them in the previous session. However, we will speak about them in a bit more detailed scenario, and we will give some examples. We'll speak about ModelViewController. It's one of the architectural pattern. It's very famous, and a lot of developers use it as it is already being tested and used. Also the layered architecture, the client-server architecture, pipe and filter architecture, and we will speak a little bit about the concept of application architectures, and we give 4 different examples which will be discussed, or at least 2 of them will be discussed in the next or the final part of this chapter, the third part of this chapter, okay? Not today, I mean not in this session, in another session. Okay, so what do we mean by architectural patterns? In brief, imagine that we have a successfully implemented software and we develop its architecture, and this architecture can be generalized, can be reused. Then we put it in a template, and then we can call it a pattern. So this is the exact idea. The patterns here actually are templates, or you can represent them as templates for architectural design of a software, where they generalize certain idea about a concept that we have in software development, because we don't have totally new ideas all the time. We have some sort of derived ideas or derived applications from available or already available applications. So these patterns can be actually used for either representing or sharing or reusing knowledge. So we already have some sort of knowledge in a sort of a template, or what we call pattern in this case, and we can either reuse it, we can represent the information or the knowledge, or we can share it using these patterns. All right, we have different types because we have different applications, and these patterns, as I said, they have been used and tested, so we don't have to retest them. They prove their efficiency in what they can apply for or used for, and also what they cannot be applied for or used for, or when they are not actually useful for some applications. Usually we represent these patterns, or the design patterns, or the architectural patterns in a tabular form or graphical form or description, as it's easier actually for the reader or the one who is interested in going through them. Now look at this, the ModelViewController. This is an architectural pattern that generalizes the idea of one problem that we have while developing software. And now I'll explain about this problem in a while. Let's just go through the description first before I tell you, practically what it means. Look at this description. Separates presentation and interaction from the system data. What does it mean, separates presentation and interaction? That means we have different units for data processing, data presentation, and the control somewhere. So this is the idea, and that's the name, that's where the name comes from, or that's how the name is being given to this pattern. We call it the MVC, or the ModelViewController, where we have 3 separate models that manage the data and its representation. The first one is the model component, okay? And this component manages the data and the associated operation, or the operations applied on the data. And we have the component that manages actually the data, or how the data is presented to the user. And then we have also a model that controls the interaction from and to the model and the view. So we have like a controller somewhere receives interactions or requests or processes some applications to both sides, and I'll show it in the illustration in a while. Okay, when can we use it? In brief, or in a simple sense, when we need to present data in different ways, or when we need actually to separate some module for processing data and another module for presenting this data. This is extremely important. Sometimes we may think about unknown future ways for representation of data. We expect like, well, we can represent data like now, for example, we can see it on the screen, but in future, maybe there will be another way to visualize this data or the view that we have. So in that case, we leave some module or some pattern, in this case, somewhere where we can adapt it to the future, you can say update, or future unexpected or unknown visualization or presentation way. What kind of advantages do we have for such a pattern? Well, when we said, since we have separation between data processing and data presentation, then it is good actually for representing data independently. So we don't care exactly much about how the data is processed, we don't care about the type of the data, so we know how to separate, or we have some distinguished process, or some borderline between these models. This is the main advantage actually. How about the disadvantages? Now, when we speak about models, 3 models, that means extra coding. So most likely we will get stuck somewhere with code complexity, especially if we are going to represent data in different ways. And that is not very good in software development. So look at this. Maybe if you couldn't understand the idea of what I was explaining a while ago, now you would understand. We have the model where we deal with data itself, its processing, whatever. And then we have this view, we represent the data by different formats or whatever it is requested by the user or the viewer in this case. And we have a controller that manages actually the process in between, makes like synchronization and request or whatever from the model, and the view gets like some communication or some instruction to be done through those using this controller. Now I give you a practical example from our life that we use it on a daily basis, the browser that we use. Now the browser has different ways for visualizing data. As you see, we have string like text, we have also the images, we have also PDF sometimes for documents. There are so many videos that can be embedded, or JavaScripts or things like that. So there are so many sort of data types that can be represented using the browser. And in that case, think about certain requests from a website. It will be processed through the controller, then we will request data somewhere from the database. Imagine that you are buying something online, so you're requesting through an HTML page, or maybe PHP, or whatever the design page that you have, the front, the one that you have. So you will use HTTP most likely, and then you will request your purchase or the item that you want to buy. And then what will happen? So the processing will be here, the model. So the controller will initiate, then we will have this processing. It will give the representation, you can say the notification or a correspondence to the view, and then you'll be able to visualize it from the browser. If there is any request or communication like this for refresh or maybe whatever, so it will be processed directly, but other things most likely will be requested through the controller that will request either update or any other further processing. Like, for example, user events. So you see data, you want to process something, you don't ask it directly from here, or not from the view, we'll ask it directly from the model. No, it will come through the controller. And that's how these models work in the this kind of pattern, the model view controller in this case. Okay, so remember, before I proceed, I got back intentionally for this one, and then I forgot for a second. Now I remember. Usually I ask these questions. I do not ask you to write this table during the exam. There is no point to do so. I may ask you, when should we use a model view controller? Or sometimes I may give you something like this. Maybe not for a browser, maybe for, let's say, we are speaking about repository, or maybe distance learning like the one we are using now. In that case, I tell you, can we apply the ModelViewController or the MVC? Is it possible? So think about it. Do we need to separate or distinguish between data processing and control, and also the presentation? If we need, then we can apply that concept. Okay, let's move a bit. Layered architecture is a bit different, where we actually create different layers for data processing and even transaction processing, and we create, or we keep these layers actually attached to one another. That means the services requested from one layer should be attached to the layer that will receive the service from. That means if I have a layer, it should be next to a layer that will expect some service or some communication from it. So it is exactly this way. So we have sub layers, and these layers will be interfaced by some way, and the way we deal with these layers is like every layer, or each layer, has its own task or role in the whole software process. Okay, now what kind of application do we have, or we may have in reality? There are so many, and I'll give you practical examples, but think about layered architecture, where we place things close to our operating system first, then some application, then on top of application, things that interface with us. How about the computer that we are using? Think about it. Many applications that we use now. Think about this. If we have like system support, like operating system or databases or whatever related to the machine itself as a software, of course. And then maybe we have like other core business logic, or maybe applications that actually need it as utility. And then we need to have some sort of interfacing. Before actually the user interface, we need some login, maybe some authorization. Then after that, we have the user interface. Okay. Now think about it, this program that I'm presenting the video to you with it, the PowerPoint now. If I do not have an operating system, can I run it? Well, practically now with this window-based system, it's not possible. I cannot do it. There is no way. So I need the system support, the operating system, and then next to that, I can place my PowerPoint or the Microsoft Office or whatever, if you think about it as a whole package. Then if I code it, if I create a password to it, in order for me to use it, to use an interface, then I need some sort of authentication and authorization in that case. Okay. Now think about the iLearn, or think about the environment that we are using, the MOOLs that we are using for distance learning, for example. In this case, we have different layers. The lowest one in these layers you may think about is the utility service, where we have authentication, user storage, maybe database and things like that. Then after that, we have some application service, email messaging, video conferencing, the way we add the files, we share the videos, all these things. Also the marking, quizzes, etc. Also configuration for groups, enrolling student or enrolling student, so it could be like that. Then we have also the identity, how to access as a student, as an instructor, maybe as an admin. Then we have the browser-based interface. It could be, nowadays, it could be an app. You can download it to your mobile phone, or it could be also just through the browser that we use from our machines directly with no application. Okay. But it's a layered, architecture. So what kind of exam questions I may ask? I may again ask, think about some certain application that we have in our reality, and I tell you, can we apply a layered architecture or not? So you need to think about that application. If it is like iLearn, for example, if it is like maybe also video sharing like YouTube, or any other application. In that sense, can we apply the layered architecture for it in development? Well, the answer is yes, if it applies a similar concept while developing it. Okay. Client-server architecture, this is a bit different. When we have different servers and a number of clients that are interested in accessing the services provided by these servers. Think about sharing a printer, for example, by different PCs. So we need a network and we need a shared services, some service like a printer. We don't have to set a printer for each PC. We can have a printer for maybe 10 individuals or 10 computers, and you can print using that sharing printer. And this is exactly a client server. It's not necessarily printing. It could be video sharing. It could be maybe photo sharing. It could be any other service. So this is the exact idea. We can be clients and accessing some services based on a network. So we need a network. So for such a client-server architecture, we need a network, not necessarily internet, it depends. Now we're using internet by default. Why? Because the concept of networking itself is useless without it nowadays. So we are actually getting a network connection for what? For the internet, not like before, like 30 years ago. The concept of networking was not just restricted to internet. Internet came like 95, became popular, 96 became commercial. So the idea is not exactly we are just looking for internet as a connection. No, we are looking because of its popularity, and so actually it override the need for any other networking other than its own the internet. Okay, there are other applications for local networking for security purposes and so on, but still we need a network for client-server architecture. So if you think about the description, as we said, we have a client and server. So a client and the server, or number of clients and the server. Okay, so we have a shared service to be provided by the server, and we have different clients accessing through a network. When to use it? So when we have a database for some certain services to be shared, or maybe different locations. Think about YouTube. It's exactly client and server. We use YouTube, for example, from different locations of the world, and we have some certain servers around the world to support the YouTube functionality. Okay, the same thing applies also to your distance learning environment, where we have services to be provided, different modules now, different servers, not just one server, because there are like, you can say somehow separate servers for different applications within the iLearn itself, or within the distance learning environment itself. How about the advantages? Well, obviously we can share the services. So it's like a distributed service across a network, and this is extremely useful. We don't have to provide a server for each client, okay? And that's good actually, especially for remote locations or remote clients. How about disadvantages? We need a network. This is a disadvantage. So in order for you to get to the service, you need a network. What does it mean, needing a network? How about if the network is not available? What will happen? You can't get the service. If the network gets any attack, like denial of service, because this is a service, if like a flood of a service request, what will happen? It will terminate the service to everybody, and this is also another disadvantage. So look at the way we may have an internet now. We speak about internet because we usually use it as our main networking scenario or mechanism worldwide. We may have different clients, and these clients may access to any of these services through the server. It doesn't matter what type of services, video like YouTube, for example, or maybe web server, or maybe a repository for some files, or PDF, or maybe ebooks, or whatever. Okay. Pipe and filter. Imagine that we think of the data as a procedure, as a unit, and where we need to apply some procedure in it. Once this procedure is applied, we call this stage or transaction, we call it filtering. once it is done, we apply some procedure, we filter the data, we come up with the new data, and we pass it to another stage. So this is what we call pipe and filter. So each stage is a filter, and we pass the data through like a pipeline. It's exactly like a pipe that we pass the data through it, and it comes from the concept of Unix. Actually, Unix is a very old system. I'm sure you guys are not familiar with it. I mean, those who are involved with this class, but I mean, simply the idea was like processing some data, creating new data. That means filtering it, passing it over a pipeline. So this is the idea. We have a sequential transformation of data from one stage to another, or from one filter to another. Okay. So this is not exactly suitable for interactive systems. We cannot exactly apply it for interactive systems. Why? If we have some interaction, we cannot just filter the data and process it and forget about it. No, we need some two-way communication, or maybe some feedback. In that case, yeah, it's not exactly applicable. So I explained about the description. It's like the processing of data, or the data processing component, we call it a filter, and where we process the data over discrete tasks, from one task to another, from one processing to another, from one filter to another. This is what we call pipe. So it's, we transform the data, or we filter it, we pass it over the processing line, and that's exactly the description. And it's a general idea of software architecture. We have a lot of software applications that fit the pipe and filter. I'll give you one example after a while. When we can use it, when we think about processing applications, think about actually payment over the internet, paying your bill maybe, or paying for some utility or anything. That is exactly a filter and pipe and filter exactly specification of filtering or processing and then passing through a pipeline of process. How about the advantages? It's too simple actually, straightforward. We have one process, then pass to next, one process, then pass to next. So we process, we filter, and sequentially transform to other filters or other processing components. And in that case, we can add components if it is needed. So we can add, we can grow bigger if it is needed. How about the disadvantages? Now, one thing, it's one way. So in order for you to get the feedback, you have to manipulate the whole mechanism, and maybe you will not even end up with having a proper representation of pipe and filter. This is number one. Number two, we said we can grow bigger. Growing bigger means having overloaded actually stages, and this creates overhead, too much or excessive processing, and that's not good. Increasing the processing ability will take actually it will create complexity and overhead in the system, and that's not recommended in software industry. Now look at this example. As I said, the payment. When you make a payment, we have different tasks like pipeline, exactly, issue a receipt, and here find the payment due, for example, issue a payment reminder, maybe you have some payments. So these are separate tasks, and once the task is done, processed, we go to the next, and so on. Okay, application architectures. The concept of application architecture is exactly specialists look into the architectural patterns or the way software is actually developed. Then they thought about, wait a minute, how about business? Well, we have a lot in common in business, like issuing maybe payslip, or issuing whatever related to maybe contract related to details of an employee and details of a company, or whatsoever you can count. These are common, applied to many businesses or all businesses somehow. So they said, how about if we develop a concept, we call it application architectures. So we have in business so many applications, we can create a generic architecture, or some generic architectures where we can instantiate them somehow, and then we adapt their instance to our own application. And this is exactly what they did. So how can we use, or for what purposes can we use the application architectures? We can think of them as a starting point for an architectural design. Let's say you are just a beginner. You don't know exactly how to design an architecture or how to come up with an architectural design. Well, you can look for application architecture and compare it to your ideas and see, okay? Then maybe you will check which one is suitable. You can start with it as an architectural design. How about if you have your own idea, if you developed your own architectural design, you are not interested in having any template or any application architecture, you created your own one. How about if you use these application architectures as a checklist? What's missing in your own? This is a very good, you can say, advantage. Also, we can use the application architectures for organizing the teamwork effort. It's extremely useful. Why? Because it actually, you can, through it, you can assign some tasks based on some modules or components. Also, you may think about thinking about the components that you may reuse in future. So we may have some components that can be reused in future. You can highlight them in this from these architectures, and that will allow you to later on get benefit from these components, or take them without creating them from scratch again. You can use their vocabulary. What does it mean? That means sometimes you need to develop an architecture or an architectural design for some application, but this application, you are not exactly familiar with its own jargons or with its own vocabulary. You can use some of the applications that are already available in that field, and you can check its own vocabulary and apply it to your own application or to your own design or architectural design. We have so many examples. We have the data processing application where we actually centralize all our processes around the data. So it's data driven. Everything related to it is about data. And we will explain about those in the third part, okay? I'll just explain about them as examples now. We will dive in them deeper in the next part, or the third part. Transaction processing application, where we actually center not around the data driven, no, around the data itself. So think about when you book flight, or when you want to reach some information from a database. So it's based on a transaction that you want to take, but it's centralized around the data, okay? So you have some database that can be applied based on the request of the user, or sometimes from the central controller. Event processing is opposite to data. We don't exactly process we don't centralize the application around data processing. It's not motivated or driven by data, rather it is driven by events. So the data is minimum in this case. You may think about events as any action that actually triggers some sort of series of consequences or series of actions in the system. And this is exactly available a lot in our reality with minimum amount of data processing. There are many applications. We'll speak about them in next part, or the third part of this chapter. Also, language processing. This is a totally different scenario where we have like an architectural design for the language processing itself, like for example Java or C or C++ or whatever language you may think. These are programming languages, how they are designed in reality based on the based on computational view of our machines. So think about whether the language is interpreted or compiled, and maybe you think also about the architecture of these languages, how they may fit to any future language that we may need to create, or we are still working on and developing. So these were just examples, as I said, for the application type. We will dive further, especially with the transaction and language processing in the third part of this chapter. Until then, have a good time. Goodbye.